Okay, I'm Alex Bly. I'm the CTO and COO of a company called Flexient. What I'm going to talk to you today about has sort of three main sections. Who are Flexient, what's cloud technology, and how do we recruit? So only about a third of this is on recruitment. Sorry about that. A little bit about us. We produce cloud computing orchestration software. That is software that allows telecom companies, data center operators, service providers to offer cloud computing services to their customers. And the specific type of service that we enable them to offer is what's called infrastructure as a service software, which is software that allows you to have in the cloud something that looks like a conventional server. And if you're familiar with Amazon's EC2 service, which is their elastic cloud computing service, that's probably the poster child for that. We're based in Livingston. We're about 22 people. We're privately owned, so we sort of do a capital raise of 600 to £1 million every 6 months, which is interesting. And we're pretty technically focused, so we have 8 developers. We have over 50% of the company is technical, so that includes QA, operations and support. That's changing a bit. We're 2 and a bit years old. We spun out of a web hosting company, and we've got to that stage where we're really now growing the sales and marketing part of the company, but we're still very much focused on technology. If you came in from another environment, you think, gosh, these guys are pretty technical. I'm going to give you a really quick introduction to cloud technology. This thing up here is a cycle that Gartner did, called Gartner's hype cycle, and I don't know whether you can read that at the back, but this is called the peak of inflated expectations, followed rapidly by the trough of disillusionment. So we're sort of at the top of here in cloud computing at the moment. It's a really hot area. One thing that no cloud computing company has, no cloud computing presentation doesn't have is a definition of cloud computing. So the sort of taxi driver's definition is it's computers on the internet in it, and that's actually not as stupid as you might think. That's roughly what it is, in fact. But I'm going to put it in a bit of a historical context. First personal computer was roughly 2400 BC. Not a lot happened for, 3,000 years odd, until Babbage's difference engine was invented. It was too expensive to build, so the money dried up and it never got finished. So there's a sort of useful lesson about putting technology in a commercial context there. And 1943, first modern computer was a code-breaking computer called Colossus. Again, unlimited government funding. It's great what you can do when you've got lots of money. But actually, more to the point, Leo 1 was the first commercial computer. Ran J. Lyons and Co. tea houses. They're mainly used to calculate payroll and inventory. What they discovered when they built this thing in 1951, only 5 years later, was that they could sell time on this computer to other users. It was the first known example of a private institution selling computer time. Come 1960s, you had mainframe computers, huge, expensive beasts that ran jobs often very slowly. But actually, basically, this is what cloud computing is. It's mainframe computers all over again. So you have a single large compute resource being shared amongst many users, and that resource is remote from the end users themselves. It's an outsourcing model. It's compute as a service. There's a seminal book, which you can read if you're really interested, called The Challenge of the Computer Utility by a chap called Douglas Parkhill. He noted that computers cost, in the money at the time, $2 million, which is a huge amount of money now. And then there are O&M costs, operation and maintenance costs on top of that. But you could rent them out. These mainframe operators were renting them out for $450 an hour. Now, if you do the sums on that, that's $38 million a year. So there's a pretty good profit margin there. If you buy something one-off for $2 million and rent it for $38 million a year, you think, oh, I've got a good business there. And what they were doing is discovering that you got enormous economies of scale from improved utilization. But mainframes had a lot of problems at the time. They had no high-speed networks, they were not interactive, and they really only ran batch jobs. So you had to wait 24 hours for your results to come back, normally on a set of punch cards. So in the 1980s, with the era of the personal computer. Bring your computing close to the user. It brought huge amounts of immediacy and flexibility. But the problem was the computing was only personal. I ripped this off from another presentation that says remember floppy disks. I'm sort of presuming that a lot of people in this room actually don't remember floppy disks because they preceded them. But imagine having to take your data around on, what was it, a 1.4 megabyte floppy disk. Wasn't really very useful. And the maintenance costs on these things were huge because they always went wrong. As you can see, my personal computer did not boot up the way I thought it was, and it's a Mac, so that's really disappointing. So what we have today is cloud computing, which combines these two. So in essence, we're back to the mainframe model where our computing resources are remote from the user. They're in the cloud. They're their computers on the internet. There's bits going on locally as well. So what the untold story is that your mobile device here, which accesses things on the cloud, has actually got quite a big CPU in, and it's actually doing a lot of the work itself, and that's why it's different from sort of traditional client-server technologies. And that's been facilitated by fast and reliable communications technology. So things like the internet, which is really quite new in computing terms, believe it or not, ADSL, 3G, have allowed this sort of enhanced client-server model to work very well. And that allows shared and pooled resources to work with a degree of immediacy that neither the mainframe nor the personal computer themselves allowed. So just a little bit about what the philosophy of cloud computing is. Cloud's not really a technology. That's a big lie from technology vendors. It's not an architecture. It's a philosophy of the way you might design an architecture or the way you might put a system together. And like most things that sort of succeed and take off, it's really driven by economics and not by technology. So I came up with a random selection of words that describe it, and that's mainly so that their initial letters spell cucumber, but I didn't quite manage to get it with the middle one in the middle. So it's more cost effective. If you don't have something which is more cost effective than a custom deployment, why put your thing in the cloud? Why go to Amazon or go to one of my customers and put your technology in the cloud if you could build a server farm yourself and it would work fine? It's done on a utility basis. Now, what that means is that you have people who are purchasing computer services by the hour, much the same way as you buy your gas or electricity. And that's a term from Douglas Parkhill's book called utility computing. So it normally means pay as you go or something roughly like that. It's a commodity-based service. It's provisioned at enormous scale. If you look at Amazon's data centers, and there are many of them, they're 200,000 square foot floor plate buildings with about 20 megawatts of electricity going into each one of them. They are full of racks, full of computers. We talk about universality, and that's about homogeneous service components. The idea is you build, rather than build computing deployments which are different for each application, you build a homogeneous mass of computing resource and allow those computing resources to be used for lots of different tasks, but fundamentally the building blocks are homogeneous. It's multi-tenant, and that means, oh yeah, that's the next one, isn't it? It's multi-tenant. That means that you've got many different users using the same infrastructure, not being able to affect each other, not being able to break into each other's computers and so forth, and maybe seeing this underlying homogeneous infrastructure as some sort of heterogeneous means of providing multiple services. So that brings us with the idea of abstraction. The services that are provided tend to be very different from the physical resources that are underneath them. If Amazon change all of their servers, the idea is that you won't know, as a user of these services, the virtual machines that you are purchasing, or the virtual networks, or the virtual storage capacity, are entirely different from the underlying physical devices. You have the idea of elasticity. You can build, provision, and deprovision very rapidly. So just to give you an example of what that means, we provided service for a magician called Darren Brown on television. So he had one of the earlier webcasts that he did. He had some magic trick, I'm not quite sure what, that required that he thought it was going to bring a lot of people in to log in on this thing on screen. He went out and costed how much, or his people did, went out and costed how much this would cost if he was going to buy or rent a large amount of servers and put them in. And he came out with some figure that was, I think it was £100,000, because he needed a huge amount of capacity for a short time. And moreover, he didn't know in advance how much capacity he'd needed. So what we did for him was say, okay, we've got a huge amount of capacity. You can pay as you go, but more to the point, you can ramp this capacity up very quickly, depending on how many people you get accessing the site, looking at your videos online, and so forth. And then you can ramp it down again. You only pay for what you actually use. And that ability to flex the amount of service that you've got, that elasticity in service provisioning, is pretty key to cloud technology. And the last one is actually the most interesting one from a technical point of view, because these two terms seem like, that looks like an oxymoron. Reliability, build for failure. What does that mean? Well, if you build a complex system, you'll have been told things, I presume, about redundancy and RAID arrays and error correcting codes and things. Well, if you build systems that are redundant, so maybe you've got 2-for-1 redundancy, you've got a situation where I've got 2 of each of them, and if one fails, the other one will carry on. And you try and build a system like that, it works to start off with, because what are the chances of, you know, if you've got a dual power supply machine, for instance, what are the chances of both power supplies failing at once? Well, if you build that infrastructure at scale, then your chance, if you just work out whatever it is, 1/1 minus p to the n, and increase that with a number of machines, if you've got 1,000 machines, then it probably won't happen. If you've got 1,000,000 machines, you're sort of into it will definitely happen. So conventional mechanisms of building and reliability do not work at scale. If you're going to have, if you are building cloud services, you have to ensure that the whole service will cope with failure, and will cope gracefully with failure at an application level or whatever. And that's one of the differences between cloud technology and conventional enterprise computing. So what are the types of technology that we use internally? First of all, it's a huge mix. So we do what's known as conventional system programming. We've written bits of Linux kernel. We do database programming. We have a lot of Java-based middleware. We've got IP-level network programming. We've got some pretty strange storage programming. And we've got UI work in JavaScript and HTML and so forth. I think it's one of the really interesting things about the technology for me is that it's so wide in how it's spread, because there are not a lot of these stuff you cannot pick up from it. You can't say, oh, well, we'll use that framework here and bring it all in. A lot of this stuff has to be done either from scratch or is breaking new ground. So that's pretty interesting. We use a lot of virtualization. That virtualization is the technique that's really enabled the compute side of cloud computing. We use a lot of distributed systems, so highly scalable systems, autonomic systems that provision themselves. You'll see a lot of companies doing this stuff called big data, which is NoSQL databases, unconventional databases, things that have only been around for 3 or 4 years. And so there are quite a lot of interesting programming challenges. It's the phrase we normally use is not like working for a bank. I'm going to tell you a bit about the recruitment process. What I will say before I start is I've got my own views on this, which are quite strong, I expect. I've built a couple of startups before. I built one where we went from, on the technical side, about 12 employees to 130 within 2.5 years. And I have a policy that I interview everyone who gets a job. So I don't interview everyone who applies, but I interview everyone we take on the technical side, so that was quite a lot of interviews. That's because getting the right people is really key to us. You can look at it the other way around, which is that getting the wrong people is very, very expensive. Better to employ no one than the wrong people. So that's why I'm here today. What do we do today? On the development side, and this is really where our intern focus is, we do software development. Well, that's not a huge surprise, I hope. We do our main components are written in Java. We have a bit of UI work in PHP and JavaScript. We have some back-end and sort of kernel work that's done in C. And we have a lot of glue, which is sort of Perl and shell script and so forth. We're all Linux based. We're great supporters of open source software. Our entire system relies on open source software, so we sort of think it's good to support that. And I think one thing that's quite unusual for us is that what our interns do is exactly the same. They do software development. We don't have people in to do, you know, tech support or whatever it is. We're bringing people in because they're going to be developers. So just as an example, we have an intern at the moment. She, as Kim alluded to, came initially to work for us over the summer for 3 months and has stayed on part-time since then. She has been doing variously. She put in support for a different hypervisor into our back-end agent program, which is a C program, and she's been working on a distributed storage research project. So these are not, you know, these are not small things. What we do care about is we really care that you're bright. And if your grades don't demonstrate this, well, first you've got a problem anyway, but please find some other way to illustrate that. I've got 100 CVs that come to me normally, and they're full of half-truths and lies, and I need to have some way of selecting between them before I interview them, because I can't interview everyone. So I need something that makes me think, gosh, this guy or this girl must be really bright. The other thing that we're looking for, which is often is in inverse proportion to intelligence, is common sense. We want people who will actually be able to get on with stuff without asking a lot of questions, to which the answers are obvious. One of the main things that we look for is problem-solving ability. We're looking for people who are going to learn really rapidly, and the best way to learn is to solve your own problems. So most of our interview process, which I'll get onto in a bit, well, actually I'll touch on that in the next slide. I said I don't care about your work experience. I do sort of care a bit about your programming experience, because if you haven't touched a computer before, it's going to be a really long, hard slog to get you doing anything useful, no matter how clever you are. And with that, you know, a genuine enthusiasm for programming is really useful. If you've done stuff on open source projects that you can tell me about, if you've written stuff in your, in your free time that does something clever, that's much more useful to me than you telling me what you've done at university, which I know that, you know, some people are just going to be doing to get the degree. So if you've got a genuine enthusiasm, that's good. Attitude, personality, and adaptability. You know, we do have a small team. We need people who think the same way that we do. We're a relatively young lot, me excluded, but we have, you know, people who are going to fit into that team and who are going to pick up whatever we throw at them. That's pretty good. And I need you to be reasonably competent in at least one of the languages that we use. I can't teach people from scratch. So if you know Java or C, and I can start asking questions about it, then that's okay. If you don't know either of those, perhaps apply somewhere else. What do we do? So we offer a paid internship. We offer mentoring. You get mentoring if you're a C person direct from me, if you're a Java person from Gian, who leads our development team. So you've got some pretty senior people involved with you. You get an opportunity to learn stuff that's A, relevant, which well, sometimes might not be the case. B, is interesting, or at least we think it is. And C is commercially useful, and it's commercially useful both to us, which is why we've got you learning it, but it's also to you. I mean, we recognise that people coming to work for us as interns will not necessarily stick with us for life, so and might not even stick with us for the next internship or job they get on graduation. So this is stuff that an employer, a future employer, will look at your CV and think, oh, actually they've been doing something interesting. So just picking an ideal example, this is what we did with Diana. She worked with us during the holidays. She worked with us over Christmas as well, as it happens. She works for us part-time in term. She does 2 days a week, 1 day in the office and 1 day either in the office or remote. So we're quite happy with that. We give her a little bit of direction just because she asks for it, not because we demand it, in her project work. So she's got a big project that she's doing next term that she said, have you any ideas what I could do that also fit in with one of my modules and might be useful to me at work? And we were very happy to do that. It's not obviously not a requirement from our side. You know, and ideally, our reason for doing this is that ideally we'd like people to come and work for us full-time afterwards. That would be the best outcome. It's too early to prove whether this works, but that's our long-term focus. So why work for a small high-tech company rather than go and work for a bank or whatever? Well, it's sort of up close and personal. You sort of are going to understand how the business works, as well as understand how the technology works. You really do have a direct impact on what we do. We launch features and say we're putting in Zen 4 hypervisor support, or whatever it was in this case, and you think, oh, I wrote that, that's interesting. So you can point to something coherent that you've made a difference in the business, and to me that's something that's really important. We're pretty leading edge technology, so this is tomorrow's technology. A lot of the more commercial roles that you get where IT is a service within the business, they're much more interested in using, for obvious reasons, proven technology that you might refer to as yesterday's technology, so it's not as fun. You will learn more, no disrespect to any of the academics here, you will learn more working for us in 3 months than you will learn in 3 years at university, I'll guarantee that. And it's fun, and we'll pay you. So the recruitment process for us is pretty easy. We need to, this is our normal recruitment process. We sort of need to adapt this a bit for how the e-placement stuff works. But we will get from you somehow a CV and what we call a self-scoring checklist. So what this is, it's a list of technical expertise you have, and then we ask you to grade yourself from 1 to 5, from I know nothing at all to I'm an expert at this. Now, strangely enough, for internships, we don't expect people to very often say I'm an expert at this, and sometimes they get a bit of a hard time if they do say that. That's actually so that we can focus our questions at interview rather than asking you about lots of things you go, don't know anything about that. So it's much more about focusing our questions than anything else. We ask 2 types of questions at interview. We ask technical questions, and they range from the difficult to the impossible, and that's for everyone at every level. We deliberately ask questions that you will in general not know the answer to. And that's because we are not in general recruiting on skills and what you know, especially at this level. We're recruiting on how good you are at solving problems, how good you are at learning.